Good morning, ladies and gentlemen, and welcome to SolidCAM UK's webinar on 2D iMachining. I'm going to be working with SolidWorks 2014 and SolidCAM 2014. In the tradition of Blue Peter, we've actually got a part here ready to start work with. I've chosen this part because it gives us the chance to show a number of the features that can be handled with both 2D and 3D iMachining. Later on today I'll be doing this part with 3D iMachining. This morning though we'll concentrate on doing it with the 2D iMachining. Now this part is, let me put the stock on and we'll show you. We have a dimension here of 120mm by 118, so it's not a little part. It's going to take a wee while to do this, but using normal means. I'll go back to the part itself. Let's look at what we've got here. We've got several levels that we need to work on. The stock that I've set is 38.5mm thick, and there's 2mm on the top of this surface. So the first operation we're going to do is we're just going to face mill that, just as normal. After that we're going to use a 12mm tool and we're going to come down to this level and machine this as if it was, traditionally you would do it as a pocket. Well, the 2D iMachining, the roughing option, works in a very similar manner. So we choose things in the same way. We choose the stock and the inner contour, and it will machine down to that point. We'll then do a second operation at this level, and then a third operation using a smaller tool, and we will then take out this area in here. So the two tools that we'll be using will be a 12mm premium carbide end mill and a 5mm premium carbide end mill, both with 60-degree helical flutes. So let's move over into SolidCAM. I have already prepared this, so we'll open up the file. So here's our part here. As this is about iMachining, I'm not going to go through the setup here, but our coordinate system has been set and we'll have a quick look at where it is. It's bang in the centre of the part here. This wireframe depicts the extents of our stock. I've got 2.5mm on each side, a 8mm underneath to allow us to grip in the 4mm jaw, and 2mm on the top. So our first operation, the face mill, is fairly standard. We'll just take that off down to that level, and that deals with that. So our next operation here, and I'll suppress these for the moment and go through the creation of them as if we were going from new. So what do we want to do first? Let's have a look at this. We're going to take it down to this level. So our operation, add milling operation, 2D iMachining. Let's select our tool, which in this case, as I say, is an end mill. I'm going to put a holder on this just so that we can see it. It's not going to let me just now. I'll just ignore that then. Select that tool. Let's go back to the tool, because if we look in the iData here, we'll see that I've selected 7075, which is an aircraft grade aluminium. It machines beautifully, but you need to make sure that you've got plenty of coolant on it. Our tool materials premium carbide, and topology, the helical angle, we can set between 0 and 60. This is an effect on the way that it calculates the depths. Our default level is going to be 4. In actual fact, we're probably going to go up beyond that, but we can change that in the operation. So I'm going to select that tool now, And the levels that I want to work on, my upper level 0, which I will pick to choose, or sorry, is -2, and the pocket depth that we're going to is down to this level here. Okay, the technology wizard tells me that I've got one step of 10, and that's 1.8 ACP. ACP is the, if you imagine one rotation of the flute along the around the tool, this is the ratio between one full revolution per depth. Difficult thing to try and explain, but basically the nearer this is to a whole number, the more efficient, the less vibration will be generated. I'm going to take this right up to 8. In the tool, I'm going to change something here because there's a slight miscalculation in the database here, so I'm going to change this value down to a more realistic 3545. This area here allows you to, shall we say, manipulate your feeds and speeds yourself, but for most cases you leave this alone. It's just last night when I was preparing this file I noticed that there was a problem in the calculation here. So we're set there, we've got our depth, our technology here. We're going to leave 0.24 on the walls, and we're going to finish the floor. Now save and calculate this. No geometry selected. Well, that will be a good thing. So now we'll select our geometry, and I will select the outer, and in this case the geometry that we want has to come into here. So if I pick that and do an auto constant Z on it, that will select the correct geometry. My levels here, my upper level is -2. Sorry, pick the right bit, -2. And my depth again is here, is 10. Now I want this to be able to come out through the edge, so I will mark the chain as open. That will allow it to take the tool through the boundary. Now we can mark single edges or full open edges depending on what the requirements are. So we'll save and calculate this now. In actual fact, I will switch on this and we can then see this toolpath being calculated as we go. And that's the first level toolpath. We'll take this down. It's just a setting that allows you to speed up or slow down depending on how you wish it to deal with arcs and other factors. So let's simulate that. And we'll do this in Solid Verify, and I'll do it in the plane mode so we can see it more easily. Now you'll see here that in the iMachining tradition it started in the corners, took out the bits that required removal to give it the longest continuous sweep around the part. And there we are, and that's given us a time of about 53 seconds. Obviously on the machine with your block time etc, it may be a bit higher than that, but that's the first level taken down with a 12mm tool in jig time. So next part, let's go down and do the next level down, and this time we need new geometry. So again we have the external part, auto constant Z it. You can pick these individually, you don't have to use this if you don't wish to. And we'll auto constant Z this. Now you'll see that this time we have the 8 lobes. Now We'll pick our upper level here, and our depth now is to here. And basically I'm doing nothing else. Oops. Before I go any further, let's mark this as an open chain. Save and calculate, and let's simulate this now. Again, we'll do it in Solid Verify. Depends on which mode you wish to use. I find that this one is probably the best for what we're doing here. And I'll slow it down a wee bit again. So now once again you see the corners being taken away, all to get it to the point where it can go as hard as it can. And you see that lovely morphing spiral where it's going round the part at high speed. Now it's going in as far as it can. Okay, so we're looking not too bad at that. We've got our part down to that level. Right, the next part, let's save and copy this down again, because we're now going to change from iRough to iRest, and I'm going to choose a 5mm tool. Now I actually have cut this part in aluminium, and I know the whole part was done with one 5mm tool. Here I've changed it so we now use two tools. So iRest, again in the data here, I'm going to change this to a more realistic value. My levels, -12 and 10, those are exactly the same. Here we've got one step and it's showing you an ACP of 1.6. If that was between say 0.9 and 1.1, this would show green. It just means that it's closer to it. It's not something that's actually wrong. We've got the same offset here of 0.12, and we'll finish the floor again. So our motion control, and we'll see everything else is the same here. Let's save and calculate this. And it knows which operation to look for. It's the previous operation in this case, although in some things we'll actually choose which operation that we want to. So you can see there from the black that it has only done the ingress into the cuts. So here you'll see it's working its way in. Now in actual fact, because this is quite a small area, there's quite a lot of work to be done there. And this is, again, it's doing it very, very quickly. Move out onto each one and just work its way around about the part. It's very easy to take an open pocket and it rips it out nice and clean. But when you've got intricate bits like this, you have to be able to get in there and deal with those efficiently. And as you can see, it's taken a couple of minutes to clean that out. Very efficient way to do it. Okay, so what's next? We've actually roughed it down. Now we want to finish it. So what I'm going to do here is I'm going to take our very first path and I'm just going to copy that down. Copy and paste. Our tool's already in there. What we want to do now is to change this to iFinish. Now in our technology wizard, Solid Technology, the iRest data should point to iRough Contour 4 because that was the previous operation here. Our tool again, everything's set as it was before. Technology Wizard is showing 1.8 because it's near, and basically we should be able to just do this and this, this and this, and I'll turn this right down so we can see what's happening here. And you'll see that now this comes in, and unlike traditional finishing, either by using a helical approach roundabout, in keeping with the spirit of iMachining, the finish here uses as much of the tool length as it possibly can. So you don't get 7 steps down, you get 1 step down, and because of the way that it is set up, it'll either use compensation or not, depending on what you wish to use or what your control can handle. And as you see, that has finished that now to that level. Now I can save and copy again here. This time I'm going to change the tool. I could have copied the other option down, but as I say, we'll go for a variation here. And this time it will be the second one. It will be contour 5 we need to pick up for the geometry. So contour 5. The tool is already chosen. Technology, our levels now are different because we're coming from this level down to this level. And we'll save and calculate that. And we'll simulate this. And you'll see that we're now finishing the floors and finishing round about. So that's us finished down to that level. And if I run the whole lot, in simulation, we'll do that this time in a machine simulation so you can actually see it as if it were on a machine. Right, let's go. Now, as always, if anybody has any questions, if you'd like to put them through just now, I'll try and answer them in a few moments. Okay, so there's our part machined down to that level. Obviously, as this is about iMachining, I'm not going to add the drilling, etc. And that, in a nutshell, is 2D iMachining. It can be used for pocketing, open pocketing, rest roughing, and finishing, as you can see. And let's just do one more simulation on this, and we'll see what the time that we get on this part. Projected time is around 7 minutes. I would say it would probably take in the area of about 10 minutes to finish this part. And as I said before, it's about 120 mil square. and the depth there is 20 mil. So thank you very much for attending our webinar, and I'll be back on again later on today to show you 3D iMachining. Thank you very much for your time.